Deep in the darkest corners of the ocean, far away from sunlight and warmth, survival is a daily battle. This is a world where predators are always hungry, food is scarce, and weakness is punished instantly. Down here, most creatures survive by being fast, aggressive, or heavily armed. Razor-sharp teeth, crushing jaws, venom, speed, these are the usual tools of survival, but hidden among these terrifying hunters is a creature that seems completely out of place. It has no jaws, no speed, no claws, no armor. Its body is soft, floppy, and oddly shapeless. Its face looks frozen in permanent confusion, as if it can't quite believe it's still alive. By all logic, this animal should have disappeared millions of years ago, and yet, at HAS and single quotes T. meet the hagfish, a creature so strange, so revolting, and so effective at self-defense that even the ocean's most fearsome predators want nothing to do with it. In a realm dominated by violence, the hagfish survives using something far more unsettling than teeth or claws. Slime. Not just a little slime. A horrifying, suffocating, body-clogging nightmare of slime. While other animals evolved sharper weapons, the hagfish perfected a defense so disgusting that predators literally choke on it. Sharks, large fish, and other hunters learn very quickly that this is one meal they should never attempt again. And the strangest part? This strategy has worked for over 300 million years, long before dinosaurs walked the earth, before sharks ruled the oceans, before most modern fish even existed. The hagfish was already here, slimming its enemies into submission. Calling the hagfish weird is an understatement. Scientists often struggle to even classify it properly. It looks like an eel, but it isn't one. It's called a fish, but it lacks many features that define fish. It has no true jaws, no proper vertebrae, and no scales. Its skeleton is mostly cartilage, and its skin hangs loosely around its body like an oversized sock, instead of fitting neatly into our categories. The hagfish exists in a strange evolutionary gray area, and yet, despite its bizarre appearance, it is one of the most successful survivors the ocean has ever produced. Hagfish live in cold, dark marine environments all over the world. Some inhabit relatively shallow coastal waters, while others are found thousands of meters deep on the ocean floor. They prefer places where other animals fear to linger: muddy bottoms, deep trenches, and areas littered with decaying remains, because that's where their food comes from. Hagfish are scavengers. When a large fish, whale, or marine mammal dies and sinks to the seafloor, it becomes a feast for these creatures. Hagfish slither toward the carcass and enter it through any available opening mouth, gills, or wounds. From there, they feed from the inside out. It's disturbing to watch, but it's incredibly efficient. Their feeding behavior helps recycle nutrients back into the deep-sea ecosystem, preventing the ocean floor from becoming a graveyard of rotting flesh. In their own grotesque way, hagfish play a crucial role in keeping the marine environment balanced, but scavenging alone doesn't explain how they've survived for hundreds of millions of years. Plenty of scavengers exist. What makes hagfish special is how they avoid becoming scavenged themselves. When a predator attacks a hagfish, the response is almost instantaneous. Along the length of its body are dozens of specialized slime glands. Inside each gland are tightly coiled protein threads and mucus cells, packed and ready like compressed springs. The moment the hagfish senses danger, these glands activate. In a fraction of a second, the hagfish ejects mucus and microscopic protein fibers into the surrounding water. As soon as seawater touches them, the fibers uncoil violently, expanding and tangling together. The mucus absorbs water, swelling rapidly. What starts as a tiny squirt becomes an enormous mass of slime. Within moments, the water around the hagfish turns into thick, sticky gel. Imagine dumping a small, Spoonful of powdered gelatin into a bathtub and watching the entire tub instantly solidify. That's what hagfish slime does. A single hagfish can produce enough slime to fill a multi-gallon container in minutes, though it rarely needs that much. Even a small release is devastating for predators. The experience is catastrophic. Fish rely on a constant flow of water through their gills to breathe. Hagfish slime clogs those gills almost instantly. The fibrous gel sticks to the mouth, gills, and face, cutting off oxygen. Predators begin to panic, shaking violently, snapping their jaws, and desperately trying to clear the slime. Many are forced to spit the hagfish out just to survive. Underwater footage shows large fish thrashing wildly, their attacks completely interrupted by this suffocating goo. Sharks, often considered unstoppable apex predators, have been observed abandoning attacks. Almost immediately after biting a hagfish, one encounter is usually enough. Predators remember after a single choking experience. Many fish avoid hagfish entirely, even when starving, but releasing slime creates a problem. How does the hagfish avoid drowning in its own defense? This is where the hagfish reveals another one of its bizarre adaptations. Hagfish bodies are incredibly flexible. They lack rigid bones and have loose skin that slides freely over their muscles. When they release slime, they perform a unique maneuver. They tie themselves into a knot starting near the tail. The hagfish loops its body and forms a loose knot. Then, using muscular contractions, it slides that knot forward along its body, like pulling a ring along a rope. This motion scrapes slime off the skin, clearing the mouth and gill openings. The knot trick serves multiple purposes. It helps them escape predators, clean off slime, gain leverage while feeding, and even wriggle free if they become stuck in tight spaces or sediment. Very few animals on Earth can tie themselves into knots. Fewer still use it as a survival tool. When a predator bites down, slime floods its mouth, while the hagfish calmly knots up and slips free. No struggle, no chase, no damage. Just discussed. This defense system works so well that hagfish have remained largely unchanged for hundreds of millions of years. Along with lampreys, they are often referred to as living fossils. Their basic body plan appears in ancient fossil records, dating back to a time when jawed fish were rare and ocean ecosystems looked nothing like they do today. During that time, Earth endured massive continental shifts, ice ages, mass extinctions, and the rise of some of the most powerful predators ever to exist. Through it all, hagfish endured, not because they were fast, not because they were strong, but because they made themselves unbearable to eat. For an animal that looks like a half-melted sock with eyes, the hagfish commands an incredible amount of respect in the ocean. Its slime-based defense isn't just a disgusting trick, it's a perfectly engineered survival system, refined over hundreds of millions of years. At the heart of this system are microscopic protein threads, stored tightly coiled inside the hagfish's slime glands. Each individual thread is thinner than a human hair, about 100 times thinner, in fact, but when released into seawater, it rapidly uncoils and expands. Some of these threads can stretch several inches long, forming an intricate three-dimensional web. This web mixes with mucus cells to create a slime that is both stretchy and sticky, thick enough to clog gills, but flexible enough to spread rapidly through the water. Scientists describe it as viscoelastic, meaning it behaves like both a liquid and a solid at the same time. For a predator, this combination is disastrous. The slime doesn't just block airflow, it adheres to surfaces. It sticks to gill filaments, mouth tissue, and even teeth. The more a predator thrashes, the deeper the slime is pulled into the respiratory system. Panic sets in quickly, and the attack is abandoned. What makes this defense even more effective is its speed. From the moment the hagfish is bitten to the moment The slime fully expands. Less than a second can pass. There is no warning, no escalation. One bite instantly turns into a breathing emergency. This is why even apex predators like sharks rarely attempt to eat hagfish more than once. In underwater observations, sharks have been seen lunging at hagfish, only to recoil almost immediately, shaking their heads violently as they try to clear their mouths. In some cases, the shark swims away entirely, leaving the hagfish untouched on the seafloor. For an animal with no jaws, no speed, and no armor, that is an extraordinary outcome. But slime isn't the hagfish's only advantage. Their entire body design supports this defense-first lifestyle. Hagfish skin is not tightly attached to their muscles like it is in most fish. Instead, it hangs loosely, creating a slippery outer layer that absorbs impact and reduces grip. This makes it extremely difficult for predators to hold on to them. Even without the slime, their lack of rigid bones also works in their favor. With mostly cartilage-based structures, hagfish can compress, twist, and bend without injury. They can squeeze through tiny openings, burrow into sediment, and survive pressure changes that would injure more rigid animals. This flexibility is especially useful during feeding. When a hagfish finds a carcass on the seafloor, it doesn't simply nibble at the outside. Instead, it anchors part of its body, often by tying itself into a knot, and uses that knot as leverage to tear off chunks of flesh. The knot slides forward and backward, increasing pulling force in a way that mimics the leverage of jaws. It's an unsettling sight, but it's incredibly effective. Despite common myths, hagfish do not actively hunt large, healthy animals like whales or sharks. They are opportunists. They may occasionally latch onto weakened or injured fish, but the vast majority of their diet comes from dead or dying organisms. In other words, hagfish are cleaners. They remove decaying matter from the ocean floor, helping recycle nutrients back into the ecosystem. Without scavengers like hagfish, the deep sea would accumulate enormous amounts of rotting biomass, disrupting food webs and chemical balance. Their role may be gross, but it is essential. Because of their ancient lineage, hagfish are often grouped with lampreys as some of the most primitive vertebrate-like animals still alive. Unlike modern fish, they lack true jaws and have only a partial vertebral structure. This places them close to the base of vertebrate evolution. Studying hagfish gives scientists rare insight into what early vertebrates may have looked like and how complex features like jaws and bones evolved over time. Despite being labeled living fossils, hagfish are not frozen in time. They have adapted gradually, fine-tuning their slime production, metabolism, and behavior to survive modern oceans just as effectively as ancient ones. Over hundreds of millions of years, they've survived mass extinctions that wiped out countless other species. Asteroid impacts, climate shifts, rising and falling sea levels, the emergence of new predators. The hagfish endured them all. And now, their most infamous feature, the slime, is attracting attention far beyond marine biology. Researchers across multiple fields are studying hagfish slime for its potential applications in human technology. Those microscopic protein threads are incredibly strong for their size, yet flexible and lightweight. Unlike synthetic fibers, they form naturally in water without the need for high temperatures or toxic chemicals. Scientists are exploring whether these threads could inspire new eco-friendly textiles, materials that are strong, biodegradable, and produced with minimal environmental impact. There is also interest in medical applications because hagfish slime expands rapidly when exposed to moisture. Researchers are investigating its potential use in wound dressings that seal quickly upon contact with blood or fluid. Others are studying whether similar materials could be used to create expandable medical gels, temporary barriers, or even internal surgical tools. Environmental scientists are also intrigued by the slime's ability to expand and trap particles. Some have suggested it could inspire new methods for containing oil spills or filtering pollutants from water. Of course, working with hagfish slime is not pleasant. Lab teams often describe it as handling an endless supply of thick nasal mucus. Once released, it sticks to everything: gloves, equipment, floors, and is notoriously difficult to clean up. Even small samples can turn a laboratory bench into a sticky disaster zone, but history has shown that nature's strangest solutions often lead to the most important breakthroughs. Spider silk, once dismissed as a curiosity, is now studied for use in body armor and medical sutures. Venoms have inspired life-saving medicines. Even bacteria have helped revolutionize genetics and biotechnology. Hagfish slime may one day join that list. Despite all this interest, hagfish remain vulnerable. In some regions, they are harvested for their skin, which is marketed as eel skin in leather products. Overfishing poses a threat, particularly because hagfish reproduce slowly and populations take a long time to recover. Protecting them is not just about saving a strange creature, it's about preserving a critical part of the deep sea ecosystem, and perhaps about preserving a living reminder that survival doesn't always favor the strongest or the fastest. Sometimes it favors the grossest. When you look at a hagfish, it's easy to assume it's an evolutionary mistake, something that slipped through the cracks of nature's quality control. It doesn't look fast, it doesn't look powerful, and it certainly doesn't look impressive. Yet this creature has survived for more than 300 million years, quietly outlasting species that were larger, stronger, and far more fearsome. The secret to that survival isn't speed or strength. It's discomfort. In the ocean, survival often comes down to one brutal question: can something eat you? For the hagfish, the answer is almost always no, not because predators can't catch it, but because they don't want to. Evolution doesn't reward beauty. It doesn't reward elegance. It rewards results, and the hagfish delivers one of the most effective results imaginable. It turns the act of eating into a life-threatening mistake. This is what makes the hagfish such a powerful example of evolutionary creativity. Instead of investing energy in jaws, armor, or lightning-fast reflexes, it invested in a defense so unpleasant that predators learn instantly. One encounter is enough. After that, the hagfish becomes invisible, not because it's hidden, but because it's remembered. Disgust, in this case, is a weapon. From an evolutionary standpoint, that's brilliant. Predators rely on memory. If an animal causes pain, choking, or panic, that memory becomes a survival lesson. Hagfish exploit that learning process perfectly. They don't need to fight. They don't need to escape. They simply need to make the experience unbearable. And they do. But this ancient survivor faces modern threats it didn't evolve to handle, while hagfish have weathered mass extinctions and global environmental shifts. Human activity introduces pressures that operate much faster than natural evolution. Commercial harvesting for leather products, accidental capture in deep-sea fishing operations, and habitat disruption all pose risks to hagfish populations. Because hagfish grow slowly and reproduce at low rates, population declines can take decades to recover, if they recover at all. That matters more than it might seem. Hagfish play a critical role in deep-sea ecosystems. By consuming decaying carcasses on the ocean floor, they recycle nutrients that would otherwise remain locked away in rotting biomass. They help maintain chemical balance and support the broader food web in one of the most extreme environments on Earth. Remove them, and the deep sea doesn't just get cleaner, it gets less stable. There's also the scientific cost. Every hagfish represents a living archive of evolutionary history. Their bodies preserve traits from a time before jaws, before complex skeletons, before the dominance of modern fish. Studying them helps scientists understand how vertebrates evolved and how life adapts under extreme pressure. And then there's the slime, the same substance that makes predators. Recoil could one day help humans solve real-world problems, from biodegradable textiles to medical materials that expand on contact with moisture. Hagfish slime has the potential to inspire technologies that are both innovative and environmentally friendly. In a world searching for sustainable solutions, even the ocean's grossest creature may have something valuable to offer. That's the great irony of the hagfish. What looks useless isn't. What looks disgusting is genius. What looks weak is nearly unbeatable. Nature doesn't care how something looks on the outside. It cares about what works. And for over 300 million years, the hagfish's strategy has worked flawlessly. So the next time you think survival belongs only to the strongest or the most beautiful, remember this slimy, jawless scavenger lurking in the dark corners of the ocean, quietly proving that sometimes the best defense is being completely unbearable to eat. If you enjoyed this deep sea mystery, let me know in the comments which creature you'd like to explore next. This channel is just getting started, and there's an entire ocean of strange, incredible life waiting beneath the surface.